Very good morning all of you. This is the last class of this course Foundation Design and Analysis. So, I have completed almost all the part of this syllabus, tried my best to cover up in depth, but there are certain parts, certain topics in details we cannot go, that will be covered in higher classes, that is in PG level. So, you can prepare well for your forthcoming examinations, that is on Sunday. Only one part was left is on your some part of the pile foundation. I thought to, before signing off, leave it to you so that you can learn in a very effective manner. So, earlier I taught you the pile foundation, how to find it out the load bearing capacity of piles in different ways, by empirical formula, by SPT, CPT, by your energy relationship, as well as actual pile load test. So, from the pile load test, load carrying capacity you can get basically from the pile load test. What we are supposed to get it, load versus displacement response, whether it is a model test or field test. So, basically you are supposed to get it load versus response, load versus displacement response. There are many ways, I only emphasize your as per Bureau of Indian Standard System. So, load response or load displacement, load settlement response by graphical method. There are many people who have given how to get your bearing capacity, load carrying capacity of the pile if you have load versus settlement responses. So, first one is your hyperbolic response method. Hyperbolic response method, it has been given by Chin 1970. Second one is your parabolic response method. It has been given by Majur Kill 1972. Then log method, given by De Beer 1967. Then is your single tangent method. Then is your double tangent method. Of course, last one is your IS code. IS code already I have explained. So, I thought before I signing off you should know all this. So, hyperbolic method, first one is your hyperbolic response or hyperbolic method. The load settlement curve is considered as a hyperbolic. The load settlement curve is considered as a hyperbola. So, it will be S by Q is equal to C1S plus C2, C1, C2 constants, S is your settlement corresponding to load Q, from the load settlement data you plot S by Q versus S. If I plot settlement versus your S by Q, it should be a straight line. Inverse of slope gives the ultimate load capacity. Inverse of slope means 1 by C1 gives the ultimate load capacity. This is first one is your hyperbolic method. Second one is your parabolic response. In this case, the load settlement curve is considered as a parabola. It considered as a parabola. So, if parabolic portion of the curve equally spaced line parallel to your load axis are drawn, for intersection point with the curve, lines parallel to settlement axis are drawn. So, basically what they want to say, if it is a parabolic, from parabolic the parabola portion and straight portions, the intersection part will be considered as a ultimate or maybe bearing capacity. Then third one is your log-log method. In both load versus settlement you plot in a log-log scale. This is my load, this is settlement. Both you plot in a log-log scale. Then you will find it out an intersection point. If I plot it, you will find it out. Sometimes what happen in load versus settlement curves, you may not get actually a failure load. As per IAS code, as per others, then in that case you have to go by log-log method. It is particularly used for lateral loaded piles. So, log load versus log settlement, you plot it, you will get a complete clear intersections. That is your you can say this is my failure settlement and this is my failure load. Then single tangent, where you apply single tangent. If I plot it load versus settlement, this is load, this is settlement, load versus settlement, my curve should come in initially linear. Look at this, non-linear. After certain time it become asymptotic to your settlement axis. Once it is asymptotic to the settlement axis, then what will happen? If I draw a tangent here, this is called a single tangent. When it is asymptotic, that means it is a straight line. If I draw a tangent here, whatever I am getting, this is my ultimate load. Then double tangent, in double tangent, let me plot it, load versus settlement. It is not necessarily asymptotic. Initial part there is a linear or elastic part straight line. You draw a tangent. At the final part also there is a straight line. You draw a tangent. Whatever you will get it intersection point, that is your ultimate load. And this is your failure settlement. If I come to your load settlement response, if you are getting load settlement response you are getting, then what you are supposed to, one is your hyperbolic response method, second is your parabolic response method, then third is your log-log method, fourth is your single tangent method, fifth is your double tangent method, sixth is your IS code. I have covered, first one I have covered pile foundation in IS code. I thought I will take it into all so that you can get an idea. There are proofs, each method having proofs. Of course, that part I have not discussed, that can be, that generally I discuss in detail in postgraduate level. Hyperbolic method has been given by Chin 1970, parabolic response has been given by Mazur 1972, log-log method has been given by DeBoer 1967, single tangent and double tangent method also provided. Some small basic part I left, I thought I should cover it up so that it will be clear to all of you. Then effect of pile driving in sand, what exactly happen? If I drive the pile inside the sand, what exactly happen? For single pile, it is basically given by for single piles as well as also pile groups, it is given. For single pile, two authors given, one is your Robin and Morrison 1964. What happen if you drive a pile in the sand for a very loose sand, particularly DR 17%, soil movement extended 3 to 4 times pile diameter, extended 3 to 4 times pile dia. If I drive a pile here, in a loose sand, soil movement extended 3 to 4 times pile diameter. If this is my D or maybe capital D, soil movement extend 3 to 4 D. Then at the tip, tip 2.5 to 3.5 dia below the tip, 2.5 to 3.5 D. Here it is varying 2.5 to 3.5 D. Similarly, in medium dense sand, where degree of compaction or degree relative density is your 35%, in that case side will be between 4.5 D to 5.5 D, that is your side part, and at the tip 3 to 4.5. Tip is your, you can say it is 3D. What has proposed by Kishida? This is one. Then if I go to same, what Kishida has been done? Japanese author, Kishida 1967. Look at the diagram. Here look at the diagram. If this is my diameter, if this is phi 1 and this will be phi 2, and this gives your 7D. What it says? Phi 1, phi prime changes linearly with distance from the original value of phi 1 prime with distance from the original value of phi 1 prime at a radius r is equal to 3.5 D to a maximum value of phi 2 at the pile tip, to a maximum value of phi 2 at tip. So, phi 2 prime is equal to phi 1 prime plus 40 degree by 2 when phi 1 prime is equal to 40 degree, is equal to 40 degree, there is no change in density. Due to pile driving. This is a popular one because most of the pile foundation construction in Japan, means foundation engineering construction in Japan, are the deep foundations because of your earthquakes. So, what it says, at the tip it will be 7 times d and phi will changes linearly from top at a distance from the original value of phi 1 prime at a radius of r is equal to 3.5 d to a maximum value of phi 2 at tip to a maximum value of phi 2, then phi 2 is equal to phi 1 prime plus 40 degree by 2. If phi 1 is equal to 40 degree, that means there will not change anything else. There will not change anything else. This is what this Kishida has been given, and it is widely used everywhere else. Then let me start with this another short one, that is your lateral loaded piles, though I have not covered it very detail. In lateral loaded piles there are two piles. Generally we say short pile as well as long pile. Short pile as well as long pile. Short piles are called rigid piles, long piles are called flexible piles. Short piles are called rigid piles, long piles are called flexible piles. So, what is the definition? You can see lot of things in a pile. Generally in a pile, how we put it, it has been put it in a dimensionless form. People ask what is its L by D ratio? Length to diameter. Sometimes if I say L by D is equal to 10 or 20, oh it is a short pile, it is a rigid pile. L by D is greater than 20 or 30, oh it is a flexible pile. This comes from the experience. So, what does it mean by your rigid pile? If I say it is rigid pile, very simple definition, failure of soil occurs before the failure of pile. Failure of soil occurs before failure of pile. Long pile or flexible pile determined by the yield movement of the pile, which may be reached before full mobilization of ultimate soil resistance. Determined by the yield moment of pile, which may be reached before full mobilization of ultimate soil resistance. What did it mean? That means pile fails earlier than your soil. In rigid pile, soil fails earlier than your pile. If other way I can define it, for long and flexible pile, maximum movement should not be greater than yield movement of pile section. Should not be greater than yield moment of pile section. So, what does it mean if I say it is a rigid pile? Simple way, it is a undergraduate level course. If I say this pile is rigid, what does it mean? Soil fails earlier than your pile. If I apply a lateral load, what will happen? Soil fails earlier than the pile will not fail. That means there will be rotation. There will be rotation with the lateral load. Because soil fails, pile does not fail. So, soil fails earlier than the pile. If I consider a long pile or flexible pile, in that case what will happen? There will be yielding or bending of the pile. At certain sections at your pile before your soil failure. That means here pile, very simple way, long pile fails earlier, than your soil, short pile soil fails earlier than your pile. So, there are different theories. Brom's theory, different theory has given to find it out, what is your short pile, long pile, how to find it out your capacities. This has been in detail in your post graduation level, not in the UG level. Then there are different part also in a group of pile, group capacity and other part also there. I think I will not cover much. So, I will stop it here. You can go through my notes, you can write me an email if you have any problem, and do well in the examinations. Wishing you all a very happy Diwali, and next semester or maybe next time, next year I am planning to float a course, interesting course, that is your application of soil mechanics, particularly your undergraduate level in details applied soil mechanics. See you all, thank you.